Hi, folks. Welcome to day 3 of evaluating a training program. On our first day, we talked about clarifying our logic model so we knew what we were measuring for. And yesterday, we talked about creating our evaluation plan. Today, we are going to pretend that we've collected some data and we're going to analyze it. And for the sake of this conversation, I have the world's simplest survey. We've only asked one question, which is about our hypothetical students' confidence riding a bike. Okay? Here are two versions of the question based on whether we employed a pre-post design or a post-only design. Okay? In the pre-post version, we are going to have asked that question, how confident do you feel riding a bike, before they took the class, and then again after the class, right? But it was exactly the same question. And in the post-only design, we're just going to ask them to think back and tell us about the effect of this class on their confidence. All right, so two ways of getting similar information. In the pre-post design, remember we had two options. We could have asked the respondents to put their name on the survey so that we're able to match one particular respondent's answer from the pre-period to the post-period. Or we might not have. We might have let them complete this anonymously. So we know how a pool answered at the beginning and we know how a pool answered at the end. All right, and we're going to talk through what to do in each of those scenarios. Now, the first thing that would have happened when you collected data like this is you assigned values to those answer choices. And you did it whether you've been taught to do it or not, but you probably would have assigned the number 4 to completely agree, 3 to somewhat agree, 2 to somewhat disagree, and 1 to completely disagree. And the reason that you did that was because you were trying to sort these answers in Excel. And when you assigned numbers, you were able to stack the answers in the order in which you want to see them. Okay? But I want you to keep in mind that that's why these answers have numbers assigned to them. There are some very important characteristics of numbers that don't apply here, right? These answers have an order, but there's some other things about numbers that they don't have, and that's going to be really important in how we can analyze and display and talk about our results. I think about this as the Yelp review problem. When Yelp started to get really big, one of the critiques of them was that, well, people are only going to write really high or really low reviews, right? You have never, probably in your experience, gone to a restaurant and said, wow, that was so average. That was the most unremarkable restaurant experience I've ever had. I really need to get on Yelp right now and write about it, right? That's never happened. You only go on Yelp when it was the best meal you ever had or the worst. So in reality, everybody has either given this restaurant 5 stars or 1 star. Yelp's response to the criticism was our average review is 3 stars, which they tried to say indicated that there was some subtlety in the evaluation and that people weren't just answering with the polls. But you can see how both of those things are true, right? If you went to the restaurant and you loved it and gave it 5 stars, and I went to the restaurant and I hated it and I gave it 1 star, the average review is 3, which reflects what nobody thought. Nobody thought this restaurant was average, right? So that's why what we are not going to do is average those numbers together. We are also not going to try to multiply or divide them, right? People who completely agree are not twice as confident as people who somewhat agree. Let me say that again. The people who completely agree are not twice as confident as the people who somewhat agree. even though 4 is twice 2, we can't do that kind of math here. That value of numbers doesn't apply in this scenario because there's no absolute 0, right? Is the mathematical reason for that. So that's another kind of math that we cannot do here. All we can do with those numbers is keep our stuff in order, right? Keep our answers in order. So what can we do? The first thing I would do is I would count up, or use Excel to help me count up, how many people responded with each of those answers, right? And I would do it for if I had the pre-post design, I would do it for the pre-data and the post data. And so let's say that at the beginning of the course, 20% of my participants said they felt very confident riding their bike. And at the end, 80% said they felt very confident. So I would highlight that number and say a lot more people were confident at the end. If I had matched, so I knew it was the same person, I could see what number of people increased their level of confidence, right? So how many people had a value at the end that was higher than their value at the beginning? Now, I'm not going to try to talk about how much higher, because again, the steps between completely agree, somewhat agree, and somewhat disagree aren't equal, right? The steps between 1 and 2 and 3 and 4 are actually all exactly the same distance, but the answers on a Likert type scale are not exactly the same distance apart. So we can't say these people increased more than these other people. We can just say something like 60% of our participants said they were more confident after than they had been at the beginning, right? Or said that they had increased. Now, if I went with the post-only design, then I would just simply say how many people said that they were more confident as a result. In marketing and some other fields, it's very common to talk about like a top 2, displaying our top 2, which in this case would be completely agree or somewhat agree, right? So I might say, 80% either completely agreed or somewhat agreed with the sentence that they were more confident after taking the class. I think there's nothing magic about the top 2. It sort of depends how many answer choices you have and what you think is important, right? If your standard is that people completely agree and feel completely confident, then why would you share data about people who sort of agree and sort of feel confident? But if you think that any confidence at all is good, then that's what you're going to represent. This is where it's a little bit more art than science, and you might represent your data a few different ways before you see what's really important, right? Before what you see what there is to see there. So let's talk now briefly about significance, because I get this question a lot. How do I know if my data is significant or my findings are significant? And let me be clear, there are at least two distinct meanings of the word significant. We might mean statistically significant, or we might just mean important. And those are different things. Statistical significance means I have 2 groups. Each of those groups has some distribution of answers centered around an average, but with a certain amount of spread outness. And the groups are far enough apart that I can definitely see that one group is different from the other, right? If they overlap a lot, we're going to say they're not statistically significant, right? They're actually very close to each other. So that's what statistical significant means. You only test for or look for statistical significance if you have another group to compare to. So if I had some participants who did not take my class and I was comparing the level of confidence in bike riding with the people who took the course versus the people who did not take the course. Then I could look for whether they are statistically significantly different. It's relatively rare that you have a control group or a comparison group to do that. Most of the time in my work, when I say significant, I mean important, right? A difference can actually be different in a statistically significant way and not be important, right? I could say, oh, I can absolutely prove it is statistically significant that, these students scored 1 point higher on the exam. And, students, parents, and teachers would say, so what? 1 point doesn't make a difference. Kids who scored 1 point higher are not more likely to go to college or not more likely to be successful. That is not an important difference, right? So something can be statistically significant and not be important. When you're thinking about what is my important, significant data to share, that's really about your program's values, and your program's goals. So if your program had a target that 100% of your participants would be comfortable riding a bike, and you are at 95, well, that's pretty significant. That's pretty important. If you started with a group where nobody was confident with riding a bike, and now 60% of them are, I think that's pretty important. I think it's significant. It's a big deal. You should report it. That's generally what we mean when we say, is this significant? Do we share? It's, what do you think in your organization, in your program, is important and worth sharing? And what is meaningful in the lives of your participants? So, are they dramatically more likely to access some resource or something because of the intervention that you've made? Okay, so that was a start on analyzing your data. Tomorrow, we're going to talk about using your data, the so what, and how do we make choices based on it. And then on Friday, we're going to talk about, once we did make a choice, how could we monitor our outcomes and understand if we were on the right track with implementing it. So if you have additional questions about analyzing survey data, pre-post designs, post designs, writing survey questions, writing Likert type questions, please put them in the comments below. I did not talk today about working with scales and how you analyze that. It's a separate case. If you're interested in it, please let me know in the comments below, and I will do another piece on that. Have a great afternoon, everybody. Talk soon.